Section 11.1 is on inverse variation. Inverse variation is an equation of the form xy equals k, where k is a non-zero constant. Compare this to direct variation, which we talked about, I believe it was back in Chapter 4, and the equation for that was y equals kx, where k was the constant of variation, and the graph of this was linear. Notice that x is multiplied by a constant every time and gives you a different y. This one's a little different. In this case, we're multiplying x times y in order to get that constant. Here's a couple examples. Determine whether each table or equation represents inverse or direct variation and explain. So for number 1 here, we have an xy table, and you'll notice that when x is 1, y is 2, when x is 4, y is 8, and so on. And looking more closely at this, you'll notice that to get each y value, so in order to get the 2, the 8, the 16, and the 4, each of the x's is multiplied by 2. So 2 times 1 gives you 2, 2 times 4 gives you 8, 2 times 8 gives you 16. So this is an example of direct variation because k is equal to 2. Every time that to get my y value, I multiply my x by 2. And the equation of this would be y equals 2x. X is multiplied by 2 in order to get my y. Second example here, so for x's 1, 2, 3, and 4, I have 24, 12, 8, and 6, excuse me. And you'll notice that I'm not multiplying each x by the same number in order to get my y, but if I multiply my x and my y, I get the same number every time. 1 times 24 is 24. 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24. So this is an example of inverse variation. And my k is 24, and the equation for this would be xy equals 24. Because multiplying x times y, I get the same number, the same constant each time. Example number 3, this is actually already in the form of inverse variation. xy equals my constant, and in this case my constant is 4. In example number 4 here, y equals x over 10, that could be written as y equals 1/10 x, and that's an example of direct variation. X is multiplied by 1/10 each time in order to get my y, and so my k is 1/10. Here's another example. Assume that y varies inversely as x. Write an inverse variation equation that relates x and y, and then graph. So this is going to be inverse variation, xy equals k. So let's plug in those numbers and multiply them. So x is 2, y is negative 4. That's my k. So my k is negative 8. So my inverse variation equation is xy equals negative 8. Now, in order to graph this, I want to make a table of values, and I'm not just going to start with x equals 0 and so on, but I'm going to pick pairs of numbers that multiply to negative 8. Okay, so I'm going to start on the low end, so I could use negative 8 and positive 1 because those two multiply to negative 8, negative 4 and positive 2, negative 2 and positive 4, negative 1 and positive 8. And notice I can't choose 0 because there's nothing I can multiply by 0 in order to get negative 8. So actually there is no, when x is 0, there is no y. And now let's use similar positive numbers. When x is 1, y is negative 8. When x is 2, y is negative 4. When x is 4, y is negative 2. And when x is 8, y is negative 1. Pick numbers that are going to work nicely. Okay, don't pick 3 and 5 because then you'd end up with fractions. Now let's graph these points and see what they look like. So when x is negative 8, y is 1. When x is negative 4, y is 2. X is negative 2, y is 4. And when x is negative 1, y is 8. And over here we have 1, negative 8. 2, negative 4, 4, negative 2, and 8, 1. And the graph is going to look like this. It curves towards the x and y axes, but never touches it, because x can never be 0 and y can never be 0. Okay, so there's a little more information about what the graph is going to look like. Be sure that you choose points that are going to fit on a 10 by 10 graph, and don't choose decimals or fractions if you don't have to. Notice that if your constant of variation k is greater than 0, that is, if it's a positive number, your graph is going to be in the first and the third quadrants. If k is a negative number, then the graph is going to be in the second and fourth quadrants. So let's take a look at this one here. Remember, this is quadrant 1, where x and y are positive, and then we go around counterclockwise. This is quadrant 2, quadrant 3, and quadrant 4. Because my k was a negative 8, my graph is going to be in quadrants 2 and 4. If k were a positive number, my graph would be in quadrants 1 and 3. And as I mentioned when we were graphing this, the graph approaches, but it will never touch the x and y axes. The axes are called asymptotes. Those are lines that a curve approaches, but never touches. And here's our last example. We need to solve. Assume that y varies inversely as x, and if y equals 8 when x equals 4, find x when y equals 2. So I'm going to start with, since this is inverse variation, I'm going to start with my inverse variation formula. And it says if y is 8 when x is 4. So x is 4, y is 8. That's going to equal my k. So k is equal to 32. So my equation is xy equals 32. So I got that information from the first part of the statement. Now I'm going to use the second part of the statement to find x when y equals 2. So let's use that equation. Xy equals 32. I don't know x, so that stays x. Y is 2, and that has to equal 32. So dividing both sides by 2, x is equal to 16. So if an inverse variation situation exists and y is 8 when x is 4, then when y is 2, x is going to be 16. So that's how you solve an inverse variation problem and how to graph an inverse variation equation.